Water is essential to life as we know it. Yet for a very long time, scientists have been puzzled over where exactly all of Earth's water came from. In fact, astronomers are now saying that it might not have come from Earth at all. So where did all the water on our planet really come from? Our home planet is the only place in the solar system that we know for sure has flowing liquid water on its surface. But this wasn't always the case. Early Earth was a scorching hot place with temperatures reaching 120 degrees Celsius. Conditions were so extreme that any water would have been vaporized long before the planet had formed. It wasn't until Earth cooled off enough for water to condense that oceans began forming. But where did all that water come from? Scientists have been trying to answer this question for decades, and there have been many theories about where our planet's water could have originated. One popular theory was that water arrived on Earth via meteorite impacts. This may sound far-fetched, but hear us out. You see, meteorites are fragments of rocks that have broken off from other bodies in space, ranging from asteroids to moons. And when they crash into planets, they can leave behind pieces of those larger objects. Some of these space rocks contain large amounts of water, making them prime candidates for delivering Earth's water. Plus, scientists have found hydrated minerals in several types of meteorites, further supporting this theory. But while this may seem like a straightforward answer, researchers are struggling to explain how much water meteorites could have delivered to Earth. You see, water isn't just made of hydrogen and oxygen. When you combine these two elements, you get H2O, or water. But where do those elements come from? The matter that makes up everything around us, including stars and planets, is called ionic matter. And it's mostly made up of protons, neutrons, and electrons. Protons and neutrons make an atom's nucleus, giving it a positive electrical charge, while electrons orbit the nucleus and carry a negative charge. Elements are defined by the number of protons an atom has. For example, an atom with 1 proton is hydrogen, and an atom with 6 protons is carbon. Now, since Earth is made of ionic matter, that means that the protons and neutrons that make up Earth's water also came from ionic matter. Scientists call this regular matter, or ionic matter for short. So if all the matter that makes up Earth came from regular matter, then all the water should have come from regular matter, too. But according to calculations, regular matter can't account for all the water on Earth. Something called the DH ratio can be used to figure out the amount of deuterium, or a heavier form of hydrogen, to hydrogen in a given sample. And scientists have calculated that if Earth's water came entirely from regular matter, the DH ratio would be lower than what we actually observe. This means that some of Earth's water must have come from something other than regular matter. One leading hypothesis is that some of Earth's water came from interstellar dust clouds called ding, 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 ding. But wait, interstellar dust clouds aren't made of regular matter. Instead, they're made of a type of matter called dark matter. Dark matter is a mysterious substance that makes up roughly 80% of all matter in the universe, but it doesn't interact with ionic matter. In fact, dark matter is completely invisible because it neither emits nor interacts with light. Scientists have never even been able to collect a sample of dark matter, so we don't know exactly what it's made of. However, we do know that dark matter exists because of the way it affects space around it. For example, scientists have observed galaxies spinning faster than they should based on the amount of regular matter that they are made of. Since we can't see dark matter directly, scientists refer to it indirectly, such as calling it dark matter or WIMPs, which stands for weakly interacting massive particles. But back to water. If some of Earth's water came from dark matter, that would explain why the DH ratio of Earth's water is higher than expected. Now, you might be wondering if dark matter makes up most of the matter in the universe, why didn't all of Earth's water come from dark matter? Well, it all has to do with how atoms are formed. You see, when matter reaches extremely high temperatures, like what we think existed during the formation of Earth, atoms break apart into their constituent protons, neutrons, and electrons. At that point, the positively charged protons attract the negatively charged electrons, forming regular matter. Electrons can only bind to 1 proton each, so any extra electrons will remain unbound. These unbound electrons are what make up dark matter. So basically, the only way dark matter can turn into regular matter is through nuclear fusion, which requires extremely high temperatures. This is why Earth's core, which reaches temperatures of 5,000 degrees Celsius, is considered a fusion reactor. Given that Earth's core is constantly producing new elements, it shouldn't be hard to find the answer to where our planet's water came from, right? Wrong. Unfortunately, no matter how hard scientists have tried, they haven't been able to detect any evidence of water molecules in Earth's core. In light of this lack of evidence, scientists have started to hypothesize that Earth's water might have formed separately and then become part of our planet over time. If this is true, that would mean that Earth and water formed independently and then came together later. But this isn't the only alternative theory. Another hypothesis suggests that Earth formed first and then captured water from space. This process would involve Earth's gravity pulling water in from other objects in the solar system. While this might sound unlikely, it is possible that volatile compounds like water could have been released from asteroids and other bodies as they approach the young sun. In fact, scientists have noted that the isotopic ratios of water on Earth are similar to those found in comets and some meteorites. This suggests that water from these objects could have been incorporated into Earth early in our planet's history. But while scientists work to figure out exactly where our planet's water came from, we can take comfort in knowing that Earth's supply of water is more secure than you might think. You see, even though Earth's water seems to be dwindling, thanks to human activity, our planet is constantly being replenished by a seemingly endless supply of water from space. Every year, Earth receives about 100 trillion liters of water from rain, snow, and other forms of precipitation. Plus, Earth's atmosphere also contains a significant amount of water vapor. And although we can't see it, this vapor makes up about 0.6% of the air we breathe. If you thought that was impressive, just wait until you hear this. The majority of Earth's water is actually stored in rocks, soil, and groundwater. In fact, at any given time, there's about 25 times more water on land than in the atmosphere. And that's just the water we can see. There's also an estimated 1.7 million cubic kilometers of water beneath Earth's surface, although scientists are still working to confirm this number. So next time you feel like Earth's water supply is running dry, just remember that our planet is constantly being replenished by an endless supply of water from space and Earth itself. And hey, at least we won't run out anytime soon. That is, unless humans manage to contaminate all of Earth's water sources or start using it for space travel. Now that you know where all the water on Earth came from, you can impress your friends and family with your newfound knowledge. Just be prepared for them to respond with, "Do I look like I care?" Then you can follow up with a well-timed eye roll and the comment, "At least I'm not as dry as you." Then everyone will laugh and you can enjoy some tasty snacks together. Snacks that you can eat thanks to the water on Earth. Speaking of tasty snacks, did you know that you can get delicious snacks delivered right to your door? And if you don't live near a place that does food delivery, it's super easy to use. All you need to do is download the app, create an account, and fill your virtual cart with tasty treats. What I love about it is that it's not just a snack delivery service. It's a fun experience. Before your snacks arrive, you'll get a text message that says road is merging or entering the danger zone. Then a real person will bring your snacks to your door in a clearly marked box or bag. It's exciting and a little bit surprising every time.